extension 1 trig. It is a hard skill to master because of the formulas, and there's so many different formulas, but the algebra itself is pretty repetitive, and if you're pretty strong with your algebra, you'll find trig really straightforward. So for me, trig was a really easy topic, whereas, like, let's say Shania, you've done now permutations and combinations, that would have been a lot harder because the questions can change, whereas this, the questions are always going to be the same. So this will be probably the question you'll get in your exam, exactly the same, cos 75. It won't even change. So just as a little recap, we will write our little formulas that we need. So for our cos expansions, they are cos A plus B, and to expand them, it becomes cos A cos B minus, so it changes, if it's a plus it becomes a minus, and then sine A sine B. If it was a sine expansion, then it's sine of the first, sine the first angle, cos the second angle, and then for sine the operation doesn't change, so if it's plus it's still a plus, and then it's cos of the first, sine of the second, and then tan A plus B equals tan A, tan of the first plus tan of the second, over 1 minus, again operation changes there, tan A multiplied by tan B. Okay. Assuming that you guys have or will eventually memorize this. I know some of the other Thursday class, they've written all the formulas down on one piece of A4 paper, and they've just stuck it in front of their wall. And I know one student pretty much memorized it all after a week by not even studying it, but just having it on her wall. So do that. You've got to memorize these. Did we do question 2 last week? Cos A equals 3 on 5, tan B equals 2 root 6 on 5. Does anyone recall if we did this one here?
No, I don't think we did.
Yeah, all right, let's do it. So the question says this: if A and B, let me make it a bit bigger. If A and B are acute, and cos A equals 3 over 5, and tan B equals 2 root 6 over 5, then simplify sine A plus B. Well, to expand sine A plus B, if I was to see that first, I would go, okay, I know that needs to be sine A cos B plus cos A sine B. Then I'm asking myself, well, okay, great, I've got cos A, but I don't have sine A. And I definitely don't have sine B and cos B, but I only have tan B. Anyone tell me a method of me being able to find sine A, given that cos A is 3 over 5?
You can draw a triangle and use SOHCAHTOA.
Ah, fantastic. Well done, Anil. So what you can do, you know that cos A realistically is just what comes from SOHCAHTOA, right? So cos A is equal to adjacent over hypotenuse. That means if I label that as A, this will be my adjacent, this will be the hypotenuse, which means using Pythagoras, I promise you, you'll get 3, 4, 5, so that becomes a 4. Which means from there you can work out what sine A is, right? Sine A equals opposite over hypotenuse, 4 over 5. So that's great, tick, tick. Same thing for tan B. I'm going to draw another triangle. So I mean, the lesson you've learned from this question is if I ever have a trig, let's call it cos, I need to find a different trig, so sine A, you're always going to draw a triangle. So if I've got tan B and I need to work out sine and cos, then again, there's your B, opposite over adjacent, 2 root 6 on adjacent, 5, using Pythagoras, 4 times 6, 4 times 6, 72. 42 plus 25, 49. Wait, 4 times 6, 24 plus 25, 49, 7. You'll get 7 using Pythagoras, and then you've got sine b. All right, is it easy now? 2 root 6 on 7, and you've got cos b adjacent over hypotenuse, 5 over 7. Come back up here, plug it all in, so it becomes 4 over 5 times cos b. Cos b is here, 5 over 7, plus cos a, 3 over 5, times sine b. Sine b is 2 root 6 on 7. Just make it look a little bit better. So common denominator is going to be 35. We can probably see that. Top is going to be 20 plus 3 times 2, 6 root 6. Any questions? No? All right. B is going to be exactly the same. You're just going to expand it, cos A. So I'm just going to leave that one. The answers are given to you, like I said, at the bottom of this document. Double angles. So we've got these particular expansions. Then we've got if these were double angles. So that means A and A, if they were the same. Double angles. So we've got sine 2A. And did we go through sine 2A last week?
No.
No, I didn't talk about double angle results or what they become, the formulas.
I don't think so.
Okay, so if you haven't written them down, then I'm guessing I haven't. Let's go here. Okay. I'll prove it for you guys right now, but you won't need to prove it. You have to memorize it because it's too time consuming to prove every time. All right, imagine you had that. The idea is for a double angle, so sine, let's say 2 theta or 2a or whatever. So that's 2 times the inside. I'll choose A. That means this B was actually an A, so then it becomes A plus A, which is 2A. Right? If that was the case, if I was to expand this, this would look something like this. Sine A, well now B is A, so cos A plus cos A sine A. So you're literally replacing your B for A. And then what happens? Sine A cos A plus cos A sine A just becomes 2 sine A cos A. In other words, I like using thetas. Sine 2 theta is equal to 2 sine theta cos theta. We get the other double angle result, cos 2 theta. This one's cos squared theta minus sine squared theta. Don't forget, you also know that sine squared theta plus cos squared theta equals to 1. So you can replace one of them to get other results, which I'll do in a second. And then the last one we've got is tan 2 theta. Tan 2 theta becomes 2 tan theta on 1 minus tan squared theta. Okay. Sine 2 theta equals 2 sine theta cos theta. Keep saying that in your head. Sine 2 theta equals 2 sine theta cos theta. All right. Cos 2 theta equals cos squared minus sine squared. The reason why it's not plus, because this guy's plus. Cos first because you're starting with cos. So cos squared theta minus sine squared theta. Now, we know cos squared theta from last week. Cos squared theta can be written as 1 minus sine squared. So I can actually create another 2 equations from this by replacing cos squared for 1 minus sine squared. And then 1 minus sine squared becomes minus 2 sine squared. Does anybody not understand what I've done from this line to this line? Replacing cos squared theta for 1 minus sine squared. And then minus sine minus sine. So that's another result. That's one result, 2 results. And then the other result would be if I had to replace sine squared theta for 1 minus cos squared. That means start from the top again. It will look like this. Cos squared theta minus, open bracket, 1 minus cos squared. Expand and simplify, you would get 2 cos squared theta minus 1. And that's your third result. How do I get 2? That becomes a positive cos squared. So positive cos squared plus cos squared becomes 2 cos squared theta and then minus 1. So you don't necessarily need to memorize these two results. They can be easily derived from this, but I know some of the kids will be eventually memorizing this, and that's a good strategy. And the reason why you would want to memorize these two is because you can write cos 2 theta as only in terms of sine, or you can write cos 2 theta only in terms of cos, and that really helps when you're trying to solve and simplify expressions. Tan 2 theta equals 2 tan theta on 1 minus tan squared theta. Okay. We have that all written down. Okay. So let's get on to this one. Sine 2a. Well, let's start with you, Novak. Sine 2a. You there? Novak, hello?
Yes, sir.
All good. All right, sine 2a. Tell me, what's the expansion of sine 2a? So that becomes 2.
Sine A plus A.
No, not sine a plus. Yeah, but hold on. So you're not going to expand it like this because you would have already memorized that sine 2 theta is 2 sine theta cos theta. So sine 2a becomes 2 sine a, and then
Cos A.
cos a.
Yeah,
Right? You
plus.
don't want to go and expand every single question because you're going to be there all day trying to do these
Oh,
questions.
yeah, fair enough.
You want to memorize your double angle results. All right, and then pretty much what's sine a? Up here, sine a was
Sine A is
4 over
4
5,
over 5.
and then times
And
by
cos
cos.
A is 3 over 5.
So the question itself, as you can see, is really easy. That's what I was trying to say with trig. The questions are really straightforward. It's the formulas that you have to memorize to even start the question. That's really, there's a lot of them. That's it. You just got to sit down for one day and memorize all the formulas. And once you do, everything in trig is easy. Good job. Thank you. 12, 24, 24 over 25. All right. Let's try the next one. Shania, let's do tan 2a, please.
So that's tan A. Sorry,
Two tan a.
2tan
Yep.
A.
Over.
Divided by 1 minus tan square A.
Beautiful. And then again, what is tan a? We'll come up here. Tan a is opposite over adjacent. So tan a equals 4 over 3.
3, yep.
So then you're going to write 2 times
4 over 3.
over
1 minus 4 over 3 squared.
That's it. And then because there's no square roots or anything in this whole expression, you can just plug all of that into the calculator and you should get an answer, which is what I'll do right now. 3.
That's minus 24 over 7.
Yep. Let's double check it. Minus 24 over 7. Was that easy?
Yep.
Again, what's the hardest bit? Just the fact that you got to know tan 2a is 2 tan a on 1 minus tan squared a. Otherwise, I mean, to substitute values, knowing the triangle is really, really straightforward. Good job. Okay. Let's try this next one. Simplify the following: cos 4a cos a minus sine 4a sine a. Queenie, cos sine sine. Okay, this is Queenie. You there?
Yeah.
Yep. So this isn't a double angle, right? This is not a double angle. You agree with that?
Yeah.
Why? Because there's a cos multiplied by cos, and then it says minus sine by sine. Now, does that look familiar to you? The fact that it looks like this, cos, cos, and then sine, sine.
Yes.
And which one does it look like up here?
Cos A plus B.
Yeah, that's it. It looks like the first one, right? Cos, cos, sine, sine. And the fact that it says minus, you now know it's meant to be a plus in the inside.
Mm-hmm.
Your first angle is A, your second angle is B. So let's have a look. This one, you now realize it's a cos question. What's your first angle?
4A.
And then plus,
A
which just becomes,
cos 5A.
and that's it. There is no, you can't, that is simplified. You can't expand that or anything. Was that easy?
Yep.
And then if you want to double check it, start with this line here. If I had to expand this, you would say cos 4A, cos A, there it is. Then you would have to write the opposite of this, which is minus, and then you would say sine 4A, sine A. Great work. Okay. Any questions up to this point here? All right. Emily, let's try the next one together. Again, you can see that it says cos, cos, and sine, sine, which means it will be a what? Emily, are you there? Oh, not working. No, I think I'll come back to you, Emily. Andy, do you mind helping us out with this one? So this becomes, again, it says cos, cos, sine, sine. So what should it become?
Cos A minus B.
Cos, yep, and then it should be minus. Good job with that. And then what's your A in this case?
2A.
2A. And then, of course, literally minus B. And then you can't simplify that, so that is full marks. Any questions? We're doing well, you guys. Okay. Next one. Sine, cos. Emily, is your mic working now? Or
I don't know. I think it was my headphones. Is it working?
yeah, no, I hear you. Yeah, I hear you now. Perfect.
I'm
All
not
right, so,
sure, but is it sine?
well, let's toss it up. Yeah, right. You're correct, but let's just look. Okay, cos needs to expand as cos, cos, sine, sine. Whereas sine, when you expand it, becomes sine, cos, and then cos, sine, which is exactly what this one looks like. So it is a sine. And then for sine, the operation does not change. So if that's a negative, this remains as a negative.
Yeah.
And then what's your first angle and what's your second angle? Literally, don't overthink it. Seriously. That would be your...
Okay, 2A minus B. 2A plus B minus 2A.
That's it. Just 2A plus B minus your second angle. So this is technically your A and this is technically your B, let's say. I get confused myself. So this is your first one, your X, and this is your second one, your Y.
Yeah.
And then, of course, 2A minus 2A just simplifies the sine B.
Yeah.
All right, beautiful. Good work. Anouk, let's try this one.
Okay.
Do you remember what pi on 4 is as a degree? Or do you remember what pi stands
Is
for?
it 90?
It's not 90.
No. 45.
Yeah, do you remember what pi stands for, firstly?
180.
Yeah, 180. So all you're doing is 180 on 4, which is 45 degrees in your calculator. All right, let's try to do this. Let's see if we can show this left-hand side becomes this right-hand side. All right. I feel like we can do that.
Yeah.
Do you remember the expansion of tan? Let's go up. So
Uh,
tan, just so you can
2
look at it,
10.
becomes no, 2 tan is for double angles. So
Okay.
this is for two different angles. This is if they were the exact same angle. So theta plus theta,
Yeah.
right? So it's not 2 tan, it's tan A plus tan B on 1 minus tan A tan B.
Yeah.
All right, let's try it. So left hand side. Expand this. What are you going to write? Tan.
X.
Yep, first one. And then if it's a minus, it stays as a minus up here. So minus tan
45.
45 degrees over 1. And then recall, if this was a plus, this became a minus. Means if this is a minus, this becomes a
Plus.
plus. Changes. And
Yeah.
then, what are you going to write?
10x times 1045.
Beautiful work. And then can you please go and put, look, it's very close to this, right? Just have a look at this. And look, you've got tan x minus 1 over 1 plus tan x. Go and put tan 45 in the
And
calculator.
45 is 1.
Is 1. So therefore,
Yeah. It's proved.
it's proven. I'll just wait for everybody. See if anyone's got any questions for us. Anyone have any questions about that? Tan x minus 1 on 1 plus tan x times 1. Tan 45, you plug it into your calculator, it becomes 1. So equals RHS. Good work. Feeling better than last week, I hope, with this. B, let's try B, and then I'll just move on. Now, B, let's try this one with Novak. Okay. What am I going to do? How am I going to fit this? We'll fit it. Yeah. All right, Novak, you ready?
Yeah.
Okay. Left-hand side. What does your gut instinct tell you to do?
Which one are we doing? B?
Yeah, B. What does your gut instincts tell you to do?
Cut? You can't. Alright, let me just write the question then. Sine 3a.
When I say gut instincts, what I'm trying to say is, if I gave you this in any other way, what would be the first thing you should be doing?
Common denominator?
Yeah, see, that's what I'm talking about.
Oh,
So you don't all of a sudden go, oh, this is trig, and I'm meant to be doing trig stuff and blah, blah. No, look, when you see fractions and they're subtracted, the first thing you've got to do is a common denominator. If they are a common denominator like this question here, all you're going to do is just expand now. You're going to expand, you're going to expand, you're going to expand, and then what will happen, the top will just become sine over cos, which becomes tan. This question, A, can I do anything to it? No, I've just got to expand. But
okay.
with your question here, no, you can't do anything yet. There's nothing to do until
Yeah.
you cross multiply and make it a common denominator. So left-hand side becomes sine 3a times by
Cos A?
cos a minus cos 3a times by,
sine.
does that ring a bell? This one
Yeah,
here?
that's
Okay,
the
cool.
formula.
We'll come, yep, good job, we'll come to that. Sine a, cos a, that's your common denominator.
Yep.
Okay, you said that's the formula. Is this sine or cos?
It's sine.
It is sine, yep. And then sine, if it's negative, it's still negative. And then what's your first angle? Yes.
Sine.
So what's your
3A.
first angle now? Yes, 3a. And what's your second angle?
A.
That's it. And then what's sine 3a take away a?
Sine 2A.
Okay, that's great. But that doesn't help us much with sine a cos a. Because remember what we're trying to get? We're trying to get our answer to become 2.
2.
So what does sine 2a become? Well, that's a double angle result now.
Aha, okay. So 2 sine A cos A.
And then, of course, what can you see?
They cut. And you get
They
2.
cut out. Too good. Let's recap that. First instincts, yeah, you got to do common denominator. And then once you do that, that's great. If you don't realize the top is the formula, then you're still going to get stuck because you might have gone and expanded this and it's just a big mess. So it's just a formula, becomes sine 2a, then you'll hopefully remember sine 2a is 2 sine a cos a. It's a pretty easy one to memorize. Otherwise, you'll look at your right hand side, you can see a 2, and you're like, well, the only way I'm going to get a 2 is like if I cancel out the bottom, which is sine a cos a, that means the top needed to become a 2 sine a cos a, and hopefully you would have found the link like that. Cross out, equals 2, equals RHS. Any questions for that one, you guys? Am I going too fast? Okay. You guys say so. Let's move. So please do the rest for homework. This one, that's 2 different questions. So there. And then that's the next question. All right, double angle results. So before we start this, let's write our results. Can anyone, I guess, help me out here and remember their sine 2 theta, cos 2 theta without looking? If they have memorized anything, let me know what you know.
Theta cos theta.
There you go. Yep. Do you know anything else? Do you know this one?
Cos theta minus 1.
Not minus, close, minus
Sine,
squared.
yeah.
Did you say 2 cos squared theta minus 1?
No.
If you said 2, but if you had said 2, that is the other one. So that was a good job.
Yeah.
If you want to get rid of the sine squared, it becomes 2 cos squared minus 1.
Okay.
Yep. And then do you remember the third one now? Since you're here? Or
1
Start
minus
with
2
1.
sine squared theta.
That's it. 1 minus 2 sine squared theta. So the way I memorize these two, if you want to know, I personally just memorize the first one, and then I think about it like this. If I don't want sine, then my sine becomes a 1, and then I just put a 2 in front of the cos squared. If I don't want so let me do that again. If I don't want a cos, I make the cos into a 1, and I put a 2 in front of the sine. Does that make sense?
Yeah.
It's just a trick I made up for myself to make it easier for me to memorize. Because the last thing you want to write, I guess, is 1 minus 2 cos squared. You can't. That's wrong, right? You can't write that. So what I pretty much told myself when I was doing this, I was like, all right, just replace cos for 1, and then it becomes minus 2. Or if I make the sine squared, if I want to get rid of sine, then it becomes a 1, and then this becomes a 2. And tan 2 theta becomes 2. Tan theta on 1 minus tan squared. All right, let's do this. Let's do these proofs. I might copy these so that we've got a little bit more room to work on here.
Sam,
Yeah,
I think we already did this.
we did these as well.
We did the top 3, A, B, C.
Okay, good. Thank you. Thank you for letting me know. I'll do a few of the other ones. So we did start double angles. I thought we would have started double angles. All right, all good. I'll do E. Sine theta on cos theta plus sine theta plus sine theta on cos theta minus sine theta. We want it to become tan 2 theta. All right. I'll do this first one by myself. Look, common denominator again, right? So, and I can tell the denominator is a difference of 2 squares. because that's a plus and that's a minus. So this becomes cos squared theta minus sine squared theta, which already to me, alarm bells should be ringing, because tan 2 theta, I could also write it as sine 2 on cos 2, and I know cos squared minus sine squared is cos 2 theta. So I'm pretty happy with that result at the bottom. Then I'm going to cross multiply. So this becomes sine theta, and then multiplied by this side, plus sine theta, multiplied by this side. Over the bottom becomes cos squared theta minus sine squared theta. Okay. This one, sine cos minus sine squared, sine cos plus sine squared. Of course, you would cross out this with this. The top, you're left with 2 sine theta cos theta. I think we can all tell the answer now. 2 sine theta cos theta is sine 2 theta. The bottom is cos 2 theta. That becomes tan 2 theta. I will do G because it involves a lot of fractions, just to show you the way I would like you to start doing your fractions. Tan 2 theta, I might just work it on here so I don't run out of space. Tan 2 theta plus tan minus tan theta over required to prove that tan 2 theta minus tan theta on tan theta plus cot theta equals tan squared. All right, who wants to do this one with me? We're going to do it together slowly, so anyone's going to put their hand up? No. Queenie, let's do this one together. You and me then. Tan 2 theta minus tan theta on, so left hand side equals. All right, Queenie. Tan 2 theta. What does that become?
2 tan theta on 1 minus tan squared theta.
Minus tan theta. Now, I don't want you guys, because you can see already that's a fraction, which I've got to make into a common denominator eventually with this. And then you're going to write it over another fraction, it's just going to get messy. So instead, you should start learning to use your division skills there. So divide, and then again, what's tan 2 theta? Well, you've already said that. And then what are you going to choose for cot? Are you going to choose cos over sine or 1 over tan?
1 over tan.
Of course you would. Everything's in tans. 1 over 10. All right, nice. So try to learn to use your division skills here. It just makes your math a lot easier, I can promise you, and less mistakes. All right, common denominator, what would it be, Queenie?
1
on the left
minus tan squared.
Yep. And then the top just remains as 2 tan theta minus, this is tan theta multiplied by?
1 minus tan squared theta.
Okay, beautiful. This, leave it as division sign, common denominator, which is?
1 minus tan squared theta.
No. So maybe this might help. What would your common denominator be for that question?
X squared.
Is it? Wait, let's get rid of that. What would your common denominator be for this question? isn't your common denominator going to be the two denominators multiplied together if they're not the same?
Yeah.
So then your common denominator here must be tan theta multiplied by 1 minus tan squared. Just because you're saying tan squared, that's 1 minus. That tan theta is not in 1 minus tan squared theta. Just like if I had this and this, your common denominator should be x minus 1. You remember that? I'm sure you do.
Yeah.
Yeah, simple. Okay, and then cross multiply. Tan theta times tan theta is 2 tan squared plus 1 minus tan squared. And you can see why I avoided writing this all over a big fraction, because it's already messy. Okay, next line. 2 tan theta minus tan theta plus tan cubed on. All right, what are you going to do now when you once it's got a common denominator? You're obviously going to simplify, but you're also going to do what?
Flip the fraction.
Yeah, you're probably going to flip it now. Tan theta 1 minus tan squared on. That becomes just tan squared theta plus 1. Yep. Don't lose track of what you're trying to find. You're trying to find tan squared eventually, all right? So, what are you going to do with this 1 minus tan squared? What happens now? Take your time, have a look at everything. I mean, you can simplify this, of course. 2 tan take away tan is just tan theta plus tan cubed. If you can't see it, I'll just keep going. I wouldn't expand, because if you remember with fractions, especially multiplying, the whole point is to factorize, it's not to expand. Can you tell what you should do next?
You cross it out.
What are you going to cross out?
1 minus tan squared theta.
Yep. And then, what else can you see?
Tan
Don't forget,
squared.
we want to get this eventually, just tan squared. We only want to, so this guy's got to go somehow.
Cross out tan squared theta.
You can't do that. Are you allowed to do that with plus 1? Are you allowed to cross out x and x squared if there's a plus there?
No.
No. Don't start making these mistakes. So here, you didn't cross out the tan squared with the tan squared. You crossed out the whole multiplication of 1 minus tan with 1 minus tan, the whole thing. Okay? So you've got to get rid of this somehow. And think of the way you were doing your algebraic fractions before. What was the whole point of them? You stuck?
Yeah.
Anybody can see what they're meant to do at this stage? I feel like some of you might know. Anouk, any idea?
Sorry?
Any idea?
What to do?
Yeah, what to do next?
You can, since it's times, you can just multiply them straight across.
Okay, you can, but then, okay, let's just do that for you for a second. Okay, you get this, and then what? Yep, I'll accept that, because it's not technically wrong.
You can factor out. You can factor out tan squared out.
That's what we wanted from the beginning. You guys got to realize, to get rid of this, you need to have exactly the same at the top. So you've got to factorize tan theta out. you had factorized tan theta, you would have just got 1 plus tan squared. Or in this case, you decided to multiply, and then you still have to factorize out. The whole point of algebraic fractions is to factorize and cancel. Can you see that now, Queenie?
Yeah.
Makes sense, right? And then that's just equals to right-hand side. So don't lose track of your basic algebraic skills. The whole point when you've got fractions is just to factorize. So here, that's why I didn't expand. See, if I expanded this, you would have overkilled it because you would have never realized these can cancel out. So the idea with fractions, an important skill to remember, is not to expand. It's always to factorize because they can cancel out. So don't expand. If you had expanded, you would have got nowhere. Factorize is the key. Good job, Nick. All right. Anyone want me to go up so they can copy it down, or okay? Like I said, there's answers already in the booklet. All the answers are here. There it is. See, I did it the same way, division, and just do it slowly, factorize, and it should work out. All right, solving trig equations. Yep, let's do these. Before I start, I will just revise what I need you to remember from last week's equations. I guess if you know how to do this one, then we should be pretty sweet. Anyone tell me what my next line would be? What would I be writing?
You'd put positive inverse sine half into the calculator.
Good job, thank you. It has to be positive. If you're doing it my way, which you should be because I don't think any of the teachers have started this yet, but you would be putting it as a positive half. We don't ever use negatives. That's important. Yep, and look, do you remember what I put on my left-hand side?
You put like quotation marks above the x or something.
Correct. I call them hats, but yeah, x quotation marks, x hat. Beautiful. And then what were you meant to do after that?
You drop your ASTC and then you circle the quadrants you want to use. So it's going to be T and C.
In this case, you're asking yourself, where is sine negative, which would be T and C, and then once you work out your angle here, which I think is 30 degrees. Let's just double check. Yes, it is. And therefore, your actual x value must be 180 plus 30, and then 360 minus. And then, of course, your last line, you'll just convert it to radians by dividing by 180 and putting a pi. Divide by 180 and putting a pi. All right, good. Okay. Anybody want more work on that before I start these harder extension 1 questions? Should we do another 1 or 2, or no, we're comfortable with that and just move on? Okay. A and B shouldn't be too hard. I probably want to start with C first. So C, sine 2x equals cos x. Emily, let's do this one together, you and me. Sine 2x. What does sine 2x equal to again?
Sine 2x.
And we're solving. So don't forget, we're not proving this time. But yeah, sine 2x becomes?
Sorry, isn't it? It's not the
2.
double
Maybe
angle.
you just remember. Yeah, that's a double angle. Maybe you remember it. 2, and then
Sine.
and then
Cos, yeah, x.
that's all. So sine 2x becomes 2 sine x cos x. Okay, equals cos x. Now, whenever we were solving, we had to make sure our our letters are on one side, and you had to equal to 0.
Yeah.
What are you going to do now?
Wouldn't you minus the cos x over?
And then now you've got 2 cos x's like this. Well, you know that's really tricky to solve, so you're not going to leave it like this. What would be your next skill that you would need to do here? You got 2 cos x's like this.
Is this the expansion ones? No.
No, it won't be. It won't be. So it won't be that. So just think of your I just said it. Think of your basic solving questions and what you were doing if you had 2 of the same things. You would be again factorizing them out.
So it becomes cos bracket.
And then bracket.
2 sine minus cos. Wait, no, 1 minus 1, sorry.
1 times, yeah. Equals 0. And then what were you writing them as when you saw like something like this? X minus 2, x plus 3 equals 0. You would write the first bracket equal to 0 and then your second bracket equal to 0?
Yeah.
Right, so what are you going to write?
Cos x, and then it's 2 sine x plus 1.
No, it would be cos x equals to 0.
Oh yeah, then 2 sine x minus 1 equals to 0.
Beautiful. And then you would solve for this. So you would say you would plus the 1.
Yeah. So then
You'll
divide it, so it becomes half. Yeah.
And then now you go ahead and do your trig, inverse cos all stations to central. So let's do that. X equals, all right, inverse cos 0. Plug that into your calculator. You're going to see 90 degrees.
Yeah. And then.
And then what do you do before you move on?
1 second.
All stations to central, ASTC.
And then you have to do where cos is positive, so it'll be A and C.
No, sorry, A and C. Yep.
And you have to figure out what it'll be, so it'll be 360 minus 90.
Beautiful, and that's it.
Yeah,
That's your 2 answers for that one. Now we're working on the right-hand side, so do the same thing again.
That would be, sorry, I'm just thinking.
That's okay. What are you thinking about? Maybe I can help you out. Because all you're trying to do is go inverse sine.
It's 30. So
yeah. Are you trying to use your triangles or anything like that? No.
And then since it's positive, we just do where sine's positive, so it's in A and S. So
correct.
Then we do 180 minus 30.
Beautiful. So your 4 answers are 90, 270, 30, and 150. And then at the end, you're just going to divide by 180, which becomes pi on 2, 270 on 180, becomes 3 pi on 2.
Yeah.
This one becomes pi on 6, and then 150 on 180, 5 pi on 6. Are you comfortable with that?
Yeah.
All right, let's have a look at what was actually extension 1. So extension 1 was literally this line to this line. Whereas the rest of this is all advanced. So your advanced students are technically meant to know how to do the rest of this. Now, obviously, because for them, they haven't done questions like this, when it's asked in an exam, so if that was asked in their advanced test, they would absolutely fail. Because they're not sure, to bring it all to one side, factorize, and that's when you guys are going to have the upper hand. You're a bit more comfortable with solving equations like this, but I'm just trying to show you this would be the extension 1 concept. The rest of this is actually advanced. It's got nothing to do with extension 1. Then all we try to do anyways, you can't have causes on 2 different sides, so we brought it onto the one side. I can see in this case I've got 2 different causes, powers of 1, so I might as well factorize it out. and then just solve. Any questions? Okay, let's do D. Solve sine 2x equals sine squared x. Okay. Let's do. All right, Shania, let's do this one together.
Okay.
Sine 2x equals sine squared x. Okay, you ready for it?
Yeah.
All right, sine 2x. What does it change to?
2 sine x cos x.
Next line, what are you going to do?
Move it to one side.
Yep, move it all to one side. That's just the golden rule, right? When you're solving, it must equal to 0. Beautiful. And then what are you going to do now?
Can I factorize? I don't know.
Yeah. But you're going to see something's going to happen, and it's okay, we'll fix it up.
Okay.
2 cos x minus sine x equals 0.
Okay, and
And
then
then this bit, yep, you can say equals 0. When this equals to 0, we're going to have a little problem because we still have cos and sine.
yep.
But, and this is when I skipped the first 2 questions, and this is what you're going to do for the first 2 questions. But what will happen is, do you remember where sine and cos come from? So sine x and cos x, what's a relationship that has sine x and cos x? What trig identity has sine x and cos x?
I can say tan, but I don't know.
You are correct. And I've told you this about yourself, Shania. Remember, your first instinct is usually right. You've got to trust yourself. So tan x is sine x on cos x, right? It's a,
Yeah.
I mean, it's a relationship that we can at least relate sine and cos to tan, and we can actually deal with tan because we can still inverse tan and do everything else we need to do. So let's see. If I actually brought this sine x over to this side again, and if I divided everything by cos x, can you see I actually get this?
Yeah.
How cool is that? Something that looked really hard to solve is actually very easy to solve. So just by realizing that the only way you can solve sine and cos is by solving for tan.
Okay.
So before we continue that question, I'll just show everybody. So if I was here, sine x equals negative cos x. The trick is you just divide by cos. That becomes tan x, which equals to negative 1. You can only do that if you've only got sine x and a cos x. So some students, and I have to say that again, only if there's sine x on one side and cos x on the other side. Some students do it for this question here. So look at this line. It's very tempting to say, hey, can I just go divide cos? If you did, you would have not had these 2 answers, cos x equals 0. The reason why you don't divide cos and divide cos is because you actually got rid of an answer here by dividing. But when you're dividing by cos here, you did not get rid of an answer. Sine over cos just becomes tan. Does that make sense, Shania?
Yep.
So your first instinct should usually be, no, let's make it equal to 0. So let me bring it over to the left-hand side and factorize. If you could do that, great, which is what we did again here. But what we realized when we did do that, unfortunately, we still have this little issue. But then I'm like, well, now I'm only left with a cos and a sine only, which I can actually bring to one side and solve for tan. Okay, you're up to this stage. sine x equals 0, what does x equal to?
Inverse sine
Of 0, yep, which is
0.
0, and then you do your all stations to central. You get 180.
Yep.
Unique question. If sine x equals to 0, you get 3 answers. So you've got 0, you've got 180. You also will have 360 degrees as a solution. The reason why you've got 360 degrees is because your domain is from 0 to 360 degrees, right? Now, if I add 360 degrees to 0, you're still at the same location, you're still here, but your angle got larger. But that angle will give you the same result as this angle because your position isn't changed. In fact, you're allowed to add as many 360s and subtract as many 360s as you like to any angle. So if you guys want to check it out, like sine 180, if I did sine 540, that still gives me 0. If I tried 540 plus 360, which is sine 900, still give me 0. Sine 1260 will still give me 0. So I can keep adding 360, but these are outside of my domain, so I usually ignore them. With 0, if I was to add 360 to it, it is still within my domain. So for sine x equals 0, you're actually going to have 3 answers. Clear? Shania, we'll continue.
Yeah.
So this one here, 2 equals tan x.
Yeah. So we need to inverse tan of 2.
And then what do you get?
63.434.
Yep, so we're going to stick with 63 degrees for now.
Yep.
And then where tan is positive, which is here and here.
Yep.
So 243. And then just divide by 180, divide by 180. Is that okay, the division of 180?
Mm-hmm.
Yeah, that's it. I'll leave it there. Are you comfortable with everything you've done there? Just have a
Yeah.
look through it from the top. We converted that using our double angle results, brought everything to one side, factorized. We found a little problem here, which we'll keep finding, and these are easy to solve. And then this was easy, just a unique case that there's 3 solutions. And that's it. Good work. Yeah, there's only one more skill left for the algebra questions. That's good. Okay, who's going to give this one a shot? F. Yeah, all right, Novak, let's do it.
Alright.
Cos 2x. What are you going to change it to?
X equals cos x. Will we change it to cos squared minus sine squared theta?
Just be careful. If you're going to use x's, then you've got to use x's. If you use theta, whatever. It doesn't matter. Just make sure. Yeah, go.
Yeah.
All right, you're here. Now what are you going to do?
Bring the cos x to the other side.
Cool. You see a problem with something?
Yes.
What?
Would it be smart to change the cos squared minus sine squared into 2 cos squared x minus 1?
Correct. That is right. So the annoying thing with this is if you can't even factorize it because you still got the sine squared here.
Yeah.
You might as well change this sine squared to 1 minus cos squared, which eventually becomes what you said, but I'll just do it slower to show you. So cos squared, and then 1 minus cos squared for sine. and then eventually cos plus cos becomes 2 cos squared x minus 1 minus good. Let me just check on everybody. Everybody's okay with that line? Does that make sense? So we couldn't factorize cos x out because there's still this sine squared. But we know what we can change sine squared to. 1 minus cos squared, and then voila. All right, Novak, I'll just rewrite this to hopefully give you a clue of what you're going to do. I hope that gives you a clue.
That's quadratic.
That is a quadratic. Good man. See, that's just a simple quadratic. Squared, power of 1, no x value. So we won't factorize it. I'll just jump in straight into my quadratic formula. So x or cos x equals minus b plus minus square root b squared minus 4 times a times c all over 2a. Plug that into my calculator. This looks like 9, so I think that becomes 3, but let's just double check. Yeah, it's 9, so it becomes 3. So 1 plus minus 3 over 4. 4 over 4 is 1. 1 take away 3 is negative half. All right, Novak, go. Cos x equals 1. What are you going to do next?
So that's cos inverse, it's 0.
Yep, and then all stations to central.
So it's 0 and 360.
Yep, beautiful. Whenever you have 0 as an answer, if you guys just want to memorize, your next answer will always have to be 360 within your domain. Okay, this one, x.
X would equal 60. Leave it positive.
0.5, it should be, but I'll just double checking it. Yep, 60. And then where is cos negative?
In tan and sine.
Yep, so my answers are going to become 180 minus.
So 120 and 200, 240. Yeah.
180 plus.
Plus 60, yeah.
And then final answer, 0, 2 pi, 120 on 180, 2 pi on 3, and 240 on 180 should be 4 pi on 3. Yep. And now we've got the last one to do. G cos 2x equals, well, I'm not even going to do it. It's exactly the same. I think you guys can tell. Instead, you're going to be subtracting sine x here. So what must you do in that case for G? What's going to happen? If this is going to become a sine x, which one are you going to replace? You would obviously replace the first one. Cos squared should become 1 minus sine squared, so everything will be in terms of sines. You'll still get a quadratic. Exactly the same thing happens, and then you'll solve. So I won't do G. I'll leave that for you guys to do for homework. Okay. Last set of formulas that you have to learn. I promise. So, T formula. It's easier to memorize a triangle for T formula than it is to memorize the actual results. So it's easier to memorize this triangle than the results that it produces. And it's not that hard. This is going to be theta. This becomes 2t. This becomes 1 minus t squared. And this becomes 1 plus t squared. From that, you can obviously get sine theta out. Sine theta is opposite over hypotenuse. So like I said, it's easier to memorize a triangle than these results. Cos theta is adjacent over hypotenuse. And tan theta is equal to 2t on 1 minus t squared. T, the letter T, T stands for tan theta on 2. So this is called T formula, or some students like to see this as half angles. So we saw double angles, which where we multiplied them by 2. These ones are going to be half of the angle, half angles. Let's see how this works. It's a simple question. It just says show that sine theta on 1 plus cos theta becomes T. How do you know to do, I don't know, let's say, how do you know to do T formula, like if it was tan theta? How would I know to use this as tan theta compared to sine over cos or something like that? Well, the question will specifically tell you given that T equals tan theta on 2. All right, so it will have to let you know that is a T formula question. And I'm sure you would realize anyways, if you saw your left-hand side, you can see there are thetas, but your right-hand side is a T. You'll know to use T formula anyways. All right, A, left-hand side, sine theta is 2T on 1 plus T squared. Divide, told you I keep writing it like this, 1 plus cos theta, so 1 plus cos. Next line, 2t on 1 plus t squared, divide, common denominator, so that becomes 1 plus t squared. And then, next line, 2t on 1 plus t squared times 1 plus t squared on, these two cancel out. Any questions at this point? I hope you all made sense to you, what I just did.
Yeah.
Andy, same thing. No issues there?
Yeah.
All right. Let's try. Yeah, let's try F. Looks a little bit more annoying. Before I start, I always need to have my little triangle out. Theta, 2t, 1 minus, 1 plus. So cos theta is 1 minus t squared on 1 plus t squared. Sine theta is 2t on 1 plus. Okay, here we go. Left hand side, 1 plus cos sine, divide 1 minus cos plus sine. Again, you can see why I've been trying to teach you to use your division skills rather than your fraction skills for questions like this. Okay, common denominator. So my common denominator is 1 plus t squared. That means you've got to multiply this one by 1 plus t squared plus 1 minus t squared plus 2t. Divide, again, common denominator still, 1 plus t squared. So that becomes 1 plus t squared. That's a minus to the whole thing. So please be careful with that. It's negative 1 plus t squared plus 2t. Plus 2t. Next line. T squared cancels. 1 plus 1 is 2. So I get 2 plus 2t. One minus 1 cancels. T squared plus t squared becomes 2t squared plus 2t. Don't lose track of what you're trying to find. 1 on t. Here we go. Factorize. And I think we got it. Again, you can tell there's not much trig involved with this. It's all algebra, which is now a good point to raise when I was trying to tell you guys term 1 algebraic skills, the most important skills you want to know. It's because everything else is based off your algebra. You don't really do anything else other than algebra moving forward. Okay, any questions? Done. Let's move on to the last bit of extension 1, which is tricky at first, but hopefully I can do it in a very easy way for you guys. 3D trig. All right, very good. I'll give you guys a few minutes break. Has anyone actually ever seen 3D trig? Has anyone actually done 3D trig before? Just so I know.
Yeah.
I done like
Yeah.
1 or 2 questions of it.
At school or just for your own time?
Oh, I found it in a THSC exam.
Okay, sure. For extension 1.
Yeah.
Yeah, yeah. All right. And who else? Novak, you said you've done it as well?
Yeah, they're doing it at school now.
Okay, so actual 3D trig.
Yeah.
And how is it? How are you finding it?
It's all right. It's just sometimes like it trips you out when you have, you know, how you sometimes need to find the slanted and the vertical.
No, there should only be elevation and bearings.
Yeah, you know how you've got, it goes, is that the one when he goes like 90 degrees and then he comes out and he connects at the bottom?
Yeah, it looks something like this.
Yeah, those ones. Yeah.
Okay. So you haven't mastered it. That's what you're trying to say.
Yeah, not completely.
Okay. Anybody else has started this at school? Emily, I think your school might have started it. Have you looked at it?
I haven't seen it, but
You haven't. Yeah.
no.
Cool. Okay. All right. Well, I will make this as easy as it can be. So it is a rather complex skill to learn. Indeed, it is a rather complex skill to learn. But I'll try to tell you what you're meant to do for almost every question and how to draw it out, and hopefully it won't be as bad as it usually is for a lot of students. So first thing we need to learn is how do we actually draw these 3D triangles. Most questions, I can tell you with safety, above 95% of questions can be drawn with the way I'm about to draw it. Now the 5% that's left, that comes up to your exposure, but the diagram will be a little bit different, but the methods are going to be exactly the same, which is what we'll see very soon. So your question that you'll get will be something like this. You're on the ground, and we've got this being the ground. Then you're going to have a tower, or a pole, or a cliff, or something like that that's sticking out of the ground. So this will be our ground, and this would be our vertical component that's actually sticking out of the ground. You have to assume that this vertical ground is right angled to the ground. So if you think of a tower, you would assume that tower is straight. So that's going to be our assumptions. So this is pretty much your diagram that you're going to have. If I was to connect everything so you can see a 3D triangle, There it is. Everybody's pretty comfortable with that. So draw that, draw it to your right-hand side, and then draw it down. Let's see how this actually works in a question. So the angle of elevation of a tower CD of height h meters from a point A due east of it, so there's A, and it's due east of it is 28 degrees. So the angle of elevation is 28 degrees. So you got to imagine that let's just say I'm here on the ground. I'll be looking at the top of the pole, and that elevation is 28 degrees. And at a point B due south of it, so if you knew it was due south in this case, which it isn't all the time, you know east and south is a right angle, and then the angle of elevation is 36 degrees. Again, imagine you're at point B. Imagine you're at point B. Again, you're going to be point B. You're going to be looking up at the pole. That angle is going to be 36 degrees. A and B are 400 meters apart and are on the same level as the base D of the tower. They're on the same level as base D, which means these are all on the ground. Okay, I'll just stop there. Have a real good think about that. Reread the question. See if you understand how I got everything out. Ask me any questions. All good? Okay. The next thing you want to know when you feel like you start getting comfortable with diagrams, with your basic trig questions, with pretty much everything you've done, actually, if I ever asked you to go and find h, and I gave you, let's say, 30 degrees and 5, your methods usually revolve around finding h specifically. So you would have done opposite over adjacent. In this case, which is tan 30 equals opposite over adjacent, and you're specifically finding h. Right? Now, in 3D trig, we don't actually go ahead and find h. So the weird thing is, the question is going to say find the height of the tower, and the way we're going to do it is a different way, but it will eventually find you the height of the tower. So you got to get that wrapped around your head. So a lot of students who actually perform poorly in the 3D trig section is because they don't understand when saying find the height, they're not actually specifically needing to find the height. It's a different way of finding height. If it's broken down for you, as I've done in this case with A and B, great. It pretty much tells you what you're meant to be doing and how to do it. If it's not broken down, which it usually isn't in an exam, and it just says find the height, you need to remember to do part A yourself. So in this question, it says show that AD is equal to H on tan 28. Okay, so that means I'm going to start from this. I know this is a right angle because from the tower to the ground, it would be a right angle as well. So this would be opposite over adjacent, which is tan, equals opposite over adjacent. So therefore I get AD equals to H on tan 28, exactly as they wanted me to find it. And find a similar expression for BD. Well, again, you'll do tan 36 equals opposite over adjacent, and therefore BD becomes H on tan 36. So what we've just found is this and this. Now the idea with 3D trig is usually the way we're going to find H is to use this triangle. And that's why it's a little bit different to your normal cases where you're usually trying to find h. In the cases in 3D trig, you're usually trying to find the bottom triangle. We know what AD is. AD is h on tan 28. We know what BD is. BD is h on tan 36. We can see that's a right angle. Do we all remember why that's a right angle there? Because it's south of it, so which means east and south has a right angle. So what I'm going to use for this bottom triangle is Pythagoras' theorem. So what you get is pretty much something like this. So as I say, AD squared plus BD squared must equal to 400 squared. Well, what's AD squared? AD squared is, I'm just going to move it over here. AD squared is h on tan 28 plus BD squared equals to 400 squared. Okay, any questions from here? Expand, I get h squared on tan 28 squared plus h squared on, and you guys can probably tell I've got an equation with only h's, so I'm obviously going to be solving for h. And that's the technique, all right? So to find h, it's usually going to be this bottom triangle. To find the bottom triangle, you usually need to have this side and this side. All right, back to it. I'm obviously going to factorize my h squared out. And then I'm going to, well, it's going to be really messy. Excuse me, it's going to be really messy for me to write. So what I'll do, I'll just write A, and I'll write this as B. And on your calculator, you're just going to go B divided by A. So we're going to try to plug this divided by this. So let's see if we can all do that. To put tan 28 squared in your calculator, by the way we do that is just put tan 28, and then once you're closing your brackets, it's just going to become squared. So that's the way it looks like in your calculator. All right, let's try to do that and see if we can all get the same answer. So the top is 400 squared, which is just 160,000. A, we've got to plug all this in. I got about 5.4. I'll wait for all of you guys to get your answers out. Tell me if you're not able to get A out.
Sam, after we put it in as a fraction, do we have to square root it?
So you got this solution technically so far?
Yeah.
Yeah, and then final answer, square root of whatever that becomes. So 160,000 over answer, and then square root. Your answer is 172 to the nearest meter. Is everybody okay with that? Please, you got to let me know right now. Okay.
I'm confused how you got 5.431.
That's it. That's what I'm trying to make sure you guys can do. So, what have you put in your calculator?
I put
One.
10, 1
1
over
over 10. It's got to be all of this, exactly as you're seeing here.
square. And then do you plus it?
And then plus, and then again another fraction. 1 over 10, 36 squared.
Yeah, thank you.
You got it? 5.4315, blah, blah, blah. And then you're just dividing it over.
Yeah, thank
Anybody
you.
else? No problems. Anybody else? And then once we do that, plug it into your calculator, 160,000 over this, and then square root. No one really wants to divide this over. That's just a big mess. So we generally just go, this is B, this is A, and then there it is. Or as you get stronger and stronger at it, you might not even write B and A for yourself. You'll just know it's the right-hand side divided by the left-hand side, and then square root. If you forgot, I've seen some students forget square rooting. Think of the number you had, it was like 20,000 or whatever. You know that's too big for something that's only 400 meters apart, for your height to be 20,000 meters. So be aware of that. Okay. If we don't have any questions, we'll do another one. Yeah. Let's recap actually. So we're going to draw triangles like this. We're usually trying to find the sides here. Going to sometimes be Pythagoras. Most of the time it's going to be a cosine rule. And then eventually you'll use that triangle to find your height. So very strange. Like for those who haven't done it, like Emily, Shania, Andy, you've got to respect the fact that it is strange that you're using a different triangle to find the height. And you've got to remember that when you're trying to actually do these questions at your own time, questions sound and say find the height, but the way you'll do it is not really going to find the height. Just be aware of that. That's the technique. Paste. All right, let's try first read. The angle of elevation of a tower CD of height h meters from a point A due east of it is 40 degrees. Full stop means stop, and that's one piece of information. So I'm going to stop. I'm going to draw what we know. CD. Height h. From a point A due east of it. So it's due east. A. 40 degrees. From a point B, the bearing of the tower is 42 degrees from B, right? So that means, oops. That means when I draw my 3D triangle, that's B. If you remember the way you do bearings, which we will be doing anyways, but we draw our compass bearings and then it is 42 degrees. So look, this bit here is 42 degrees. If that's 42, that means this bit here is 42 degrees. That's how you do bearings, so don't confuse bearings with elevations. From point B, the bearing of the tower is 42 degrees. So from B, the bearing of the tower is 42 degrees. And the angle of elevation is 35. This elevation is 35 degrees. A and B are 200 meters apart. And on the same level, and okay, I'll just stop there. Please, you've got to ask me questions now. Any issues with the bearings? We understand the difference between the bearings and the elevation. Reread it again. Tell yourself, would I have been able to draw that? Elevation A, 40 degrees. From point B, the bearing of the tower is 42 degrees. From B, the bearing is 42. So when you draw your line, you understand that is 42 and the angle of elevation is 35. Show that BDA. BDA. Alright, let's start. A. If no, there's no questions. Show that angle BDA is equal to 132. Well, if you've drawn it the way I've drawn it, you know that that's 42 degrees. That's a right angle there. So 90 plus 42 becomes 132. So you would have drawn your diagram. You would have said refer to diagram. And then all you got to write is just 42 degrees plus 90 degrees becomes 132. Any questions about that? B. Show that BD is equal to H tan 55 and find a similar expression for AD. Like I told you, you usually have to find this triangle down here. Okay, BD. BD says 55 degrees. So if I see 55, I'm obviously not thinking of this 35. I'm thinking up here. This is 55 degrees, right? So then what I'm going to choose is opposite over adjacent. So it's going to be tan 55 equals opposite over adjacent. In this case, I get BD becoming H tan 55. Find a similar expression for AD. So imagine that was 40 degrees. That means this guy must be 50 degrees. So therefore, I get tan 50 is equal to opposite over adjacent, which means H equals, AD equals H tan 50 degrees. And then C just goes hence. Now find the height of the tower. So again, you're not going to actually find the height. You've got to use this triangle down here. Anyone know what I must use to find the height for this triangle? I can't use Pythagoras.
You have to use the expressions up there?
Yep, so AD is H tan 50, so this one is H tan. And this one is H tan 55. But what equation am I going to use?
You're going to have to use non-right angle trig?
You have to use non-right angle because that's 132. And which one? Sine rule or cosine rule?
Cosine.
Cosine, because you got opposite angle. But like I told you guys before, it's either Pythagoras or cosine. It's not really going to be a sine rule question for 3D trig because you're going to be given the two sides here and you're going to be given a third side here. So always be a cosine. All right. Okay, cosine rule is this. H squared. Sorry, no, cosine rule is 200 squared. I'm going to run out of space here. So So I'm just going to move C down. 200 squared is equal to the first one squared plus the second one squared minus 2 times the first and the second times cos of the inner angle. Does anyone want me to actually write the equation out again for cosine rule? What the formula would be, or are we okay with that? C squared equals A squared plus B squared minus 2AB times cos C. Okay. Next line, leave this. No point of expanding it yet, just leave it. Next line, can you see that becomes h squared there and h squared there, and h times h is also h squared there. So what you're going to do is again factorize your h squared out. It's just a better technique to learn to factorize it out. And then what are you left with? Tan 50 squared or tan squared 50, tan squared 55 minus 2 times tan 50, tan 55 cos 132. Plug all of that into your calculator, divide 200 squared by that, and then let's see if we can get our h. Do it slowly on your calculator. I'm going to put all this in, and I recommend you doing the same. Tan 50. Okay. Can everybody confirm they got that, please?
Yeah, I got that.
Nice.
Yes.
Good.
Yeah, I got it.
Good.
I got it.
Good.
Yeah.
All right, great. That sounds good. All right. Is it a little bit better? Novak and Anouk, I mean, you guys started. Is it a bit better? Has it make a bit more sense the way I'm doing it, or is it still a bit complicated? Yeah?
Yeah, it's better.
Okay.
Yeah, it makes sense.
Let's try another one. No, just the one by one. Okay, have a read of it. Maybe draw your own diagram first. I'll give you a minute. Okay. The angle of elevation of a tower QR, height 80 meters. Okay. So this time the height is 80 meters. At a point y due east of it is 45 degrees. From another point x, the bearing of the tower is 30 degrees. I think we understand how to do these now, the way I've shown it. There, that's about 30 degrees, so now you know that means that's 30 degrees, alternate angles. Cool, and the angle of elevation is 28, so how far it's elevated from the ground is 28 degrees. The points x, y, and r are on the same level ground, which means Q is up here. Show that x, r, y is 120. Easy now. X, R, Y equals 30 degrees plus 90 degrees. Refer to diagram. B. B, show that XR is equal to 80 on tan 28. Okay, we just do the same thing again. Tan 28 is equal to opposite over adjacent. Opposite over adjacent, which means XR is equal to 80 on tan 28. RY, we do the same thing. We go tan 45 is equal to 80 on RY. Tan 45 is 1, so when I divide it, you're just going to get 80 on 1, which is 80. Any questions up to that point? Cool. This one says, hence find the distance between x and y, so you actually got to find this one this time. That's not hard. You're just going to write xy squared equals, again,
Sam, you're muted.
oh, I didn't even realize that. So you guys weren't, when was I muted from?
Just for like a couple of seconds.
Okay, so you heard all of this, A and B?
Yeah.
Okay, thank you. Xy squared, so we're going to do cosine rule here. So xy squared is equal to XR, so 80 squared on tan 28 squared, plus RY squared minus 2 times 80 on 80 tan 28 times cos of the angle. And then that's really easy, just plug all that into your calculator and let's find XY to the nearest meter. $80 on tan 28 squared plus 80 squared square root it. Okay, the answer, hopefully everybody can get, is 203 meters. Please confirm once you've got that, and we'll move on.
Sam, I got 227.
Okay. Maybe I put something wrong. Anybody else
I got it twice.
Okay. Anybody else got what Anouk just got? Anybody else got an answer yet? No. Just waiting. You put 80 squared here, right? And on tan 28 squared. No.
Yeah, I did those two things.
Plus 80 squared minus 2 times 80 on tan 28 close bracket times cos 120. And then square root answer. I don't know, like I got 203.
Yeah, I got 203.
Yeah. I know you must be doing something wrong. Read out everything you've written on your calculator.
When I did it, I got yours, and then I noticed that I didn't put tan square where the tan 28 is, and then I got his answer, 227. So I did 80 square over tan 28 square.
Yeah, which
Yeah,
is
I
right.
squared that answer at the end.
But when you don't square it, you get 203. That's what I had.
So wait, you're saying, have you written it like this in your calculator? 80 squared on tan 28 squared?
Yeah, and then the first time I did it, I accidentally forgot to put the tan square.
Square.
But then when I put tan square, I got 220, the other one.
No, you should definitely be squared like that. Okay, wait. So you're saying when you did it wrong, you got my answer, but when you did it right, you got Anouk's answer now.
Yeah, I got 227.321.
Okay, let's wait for some others, I guess.
Sam, is
I got
there
203 as well.
You got 203 as well, Novak? Okay, wait.
Yeah.
Anouk, tell me exactly what you've written. Go on your calculator.
I wrote exactly what you have at the end, but I think I squared the 80 over tan 28 at the end.
No, that shouldn't have happened.
Yeah. And when I didn't square it, I got your answer.
Okay. Yeah, no, it should be just 80 times 80 on tan 28.
Yeah.
Yeah, that's where I was messed up. I accidentally put a 10 because I read it as a 2. My bad.
Sorry, yep. Tan 28. Cos 120. Okay. All right, all good then. That's that. Yeah, I'll let you guys do those two. Let me Save this, send that. Got a little bit of time. What we'll do some of these meant to be harder advanced questions, but I think once you've done your extension 1 stuff, they look pretty easy. So let's do A. 2 sine squared theta plus sine theta equals 0. I'm obviously going to factorize sine theta out. And then I'm left with sine theta equals 0, or 2 sine theta plus 1 equals 0. Solve for this one. If we remember, the answers are going to be 0, 180, and 360. This one's going to become sine theta equals negative half, which means theta becomes 30 degrees, and then you'll just do your all stations to central. Where is sine negative? Here and here, so 180 plus and 360 minus. We're all good with that one? C, if I've got a question like C, again, I'm thinking I can't use cos squared with sine theta, so I'm going to change cos squared to 1 minus sine squared theta. Expand this becomes 6 take away 6 sine squared minus sine theta minus 5, negative 6 sine squared minus sine theta, 6 take away 5 is positive 1, and then quadratic formula, right? So you'll just go sine theta equals minus b plus minus square root of b squared minus 4 times a times c. That looks like it's positive 24, 25. So it becomes 1 plus minus 5 on negative 12, and then you get 6. 1 minus 5 is negative 4. Negative 4 over negative 12 is 1 over 3. And then you'll just solve sine theta equals negative half, which we just did up here. And you'll do sine theta equals to a third. Do we all feel comfortable with doing that now? Does it feel easier as long as you're able to get that first step out? You know, realizing that cos squared becomes 1 minus sine squared. Are we comfortable from here onwards? Quadratic formula, subbing it in, solving for all stations to central, realizing, okay, that's a negative. I can't inverse sine negative, so, you know, I've got to do it like this, and then where is sine negative, and T and C, and get my, yeah. Pretty repetitive, and this will be worth, in your advanced test, this will be worth 4 marks. So that's some serious marks to be able to get. All right, look, are we on next week actually? No, next week's public holiday. So today's our last lesson for the term. Can you guys please make sure, let me just stop this real